This is our simple movement system for our player blueprint class. We have multiple input axis keybinds set in the project settings. And here we bind each of those to an actual action so that we can move around our player. For example, we get the actor forward vector and add it to a movement input based on the axis value from our input axis move forward, which is bound to both W and S at a scale of 1 and -1. We did the same thing for move right by getting the get actor right vector. And then for our mouse input, we have look horizontal and look vertical that add controller yaw and pitch input. Now this 0.4 multiplier is just a personal preference for sensitivity, but this 0.4 can easily be upgraded to an input parameter so that each user can have their own sensitivity. Last but not least, we have a simple jump function set to the spacebar that comes with this player blueprint in Unreal. In order to grab a weapon, we start with the FPS camera component of our player blueprint class. We get its world location and forward vector and use them to perform a line trace by channel of length reach. We first check to see if something was hit. If there was something hit, we next check to make sure that it is a valid weapon by checking to make sure it has the tag valid gun. If that is true, our next check is to make sure that we are not currently holding a weapon. If we are, we will take that equipped gun and destroy it. If we're not, we move on to the next step, spawn actor. In order to know which actor to spawn, we first check the class of the hit result actor. This tells us which weapon to spawn. We cast it to a blueprint-based gun so that it will fit into our equipped gun variable. And then we attach the actor to our gun location component. Last but not least, we set holding weapon to be true so that if we run this function again, we know to destroy the gun that we just picked up before picking up a new one. On the player side, the shoot function begins by checking to ensure that the player is holding a weapon. If this is true, we move on to our next check. We need to see if we are able to shoot, and we need to make sure that the player is actually holding down the button for shoot. If both of these are true, we can move on to shooting. We first will perform a line trace by channel by getting the world location and forward vector of our FPS camera and moving them into the start and end positions. Once we've performed our line trace by channel, we make sure that we have hit something. If we have hit something, then our look at variable, which is also the target that we are shooting at, where our crosshair is landing on the environment, will be set to the location of the hit result. If we did not hit something with the line trace channel, we make sure to set this look at variable to a point far off in the player's view, still under the crosshair. Without this, the projectile would simply move towards the world origin. Now we can call the shoot function, which is attached to blueprint base gun, with the start location being the projectile spawn point, which is a component of the equipped gun, and the endpoint being our look at location. Once we've fired the projectile, we make sure to set can shoot to be false. This allows for the fire rate delay. We next grab the fire rate from the specific gun we are holding and set it as a delay before resetting can shoot to be true again, allowing us to shoot once again. On the blueprint base gun side of things, the shoot function starts off by spawning a projectile. We spawn this projectile at the world transform of our projectile spawn point. It is important to use the transform rather than just the location in this instance, so that we can change the transform of the projectile spawn point for each child class of base gun, so that we can just use one projectile mesh or one projectile blueprint, and we can change its size based on which gun we are holding. After we've spawned the projectile, we add an impulse to it, or more specifically, to the sphere static mesh component of it, which has physics enabled. To figure out which direction to send the sphere, we take in the start location and end location from the player side, which, as we will remember, is the projectile spawn point of this gun, and the end location being the hit result of the line trace by channel. We get the unit direction vector from the start location to the end location, and we multiply it by the projectile speed and a base multiplier of 1000, so that we can move in the correct direction at the correct speed for this gun, and we plug that into impulse. The projectile blueprint has two simple little functions, because most of its functionality is actually put into the base gun blueprint. All it needs here is a hit event, so that we know to destroy the actor when it hits something, and if it doesn't hit something, we give it this lifespan. By setting a timer with a lifespan variable that we can check every tick, we make sure that the actor does not stay in the scene for any longer than the lifespan default value of 3 seconds. After these 3 seconds, the destroy actor component will be called. To add some variety to my grass, I call this per instance random node a couple different times. First, for the base color, I call it here and interpolate it linearly before multiplying it by our base color, so that each instance of the grass material that is called will have a slightly different shade. Next, I use it in our simple grass wind. I call it here and again interpolate it linearly before multiplying it by our constants from over here and putting it into the additional world position offset. This allows the wind effect on each instance of the grass mesh to have a very slightly different timing. The flag has a few different parts to it. First off, the flagpole is just a simple static mesh that will be put into the scene. But the flag itself has to be imported as a skeletal mesh so we can add this wind effect to it. We make sure that it has a bone structure right where it's going to be connected to the flag. Then we activate cloth paint and make sure we paint everywhere except for right where it will be connected to the flagpole. Then we create a blueprint class with it, where we cast it to a chaos clothing interactor and set wind. On this set wind, we add a delay of 0.2 seconds that will happen over and over again, causing it to update 5 times per second. And then we make sure to use all floats as ranges for the lift of x and y and the wind velocity of x and y, so that 5 times per second, the numbers for our wind are randomized within a certain range. This allows our flag to have a nice random wind effect.